guys, I am here to talk to you about 11.3. Today we're talking about area of regular polygons. So let's go ahead and jump right in. If you notice this learning target today, we talk about how we can use trig and special right triangles to find the area of regular polygons. So this is actually stuff that we learned back in Unit 7 and Unit 8, and it's coming back around again. So if you remember those units, this section is going to be a lot easier for you. There's two main vocabulary words that we need to talk about first. And we're going to label them right here on this equilateral triangle. Let's first of all make sure we remember what a regular polygon is. That means all of the sides and angles in the polygon are the same. They're all congruent to each other. So if you have an octagon and one of the sides is 8, that means all of the sides are going to be 8. Okay? So there are these two lines here that we are focusing on, and notice they both go to the center of the individual shape, and we'll be talking about these throughout with all different sorts of regular polygons. But one of them goes from the center to a vertex, okay? And that one is called a radius. If it goes from the center to a vertex, it's going to be a radius. If it goes from the center to the side, so it cuts one of the sides in half, that one's going to have kind of a weird name. It's called the Apothem. Kind of silly sounding, but that's what it is. So those are the two new things, and you will hear me say those words today. Just remember that Apothem goes from the center to the side, and the radius goes from the center to one of the vertices on the shape. Okay. Oh, and another thing. That is the all-important formula for the day. Area equals 1/2 times the apothem. Oh, I forgot the O. Times the perimeter. So perimeter we all know how to find. The apothem, I'm going to show you some different ways to find it today. This first example, it's really just can you plug the numbers into the formula. Our formula is area equals 1/2. Notice area is capitalized and the apothem is lowercase. 1/2 area times perimeter, 1/2 apothem times perimeter. And we just need to plug these things in. So my apothem is going to be 16. Notice this is not a radius, it's an apothem. So 16. And then the perimeter of the shape, we have to figure it out. So first things first, remember that regular polygons, all the sides are going to be the same. So if one side's 15.4, they all are. So there's 1, 2, 3, 4, 5, 6, 7 sides on this shape. So to find the perimeter, you're going to take 7 and multiply it by the length of one side, which is 15.4. And when we multiply that, we will get 107.8. Okay? So I'm going to plug that in. So it's 1/2 times the apothem, which is 16, times the perimeter, which is 107.8. And then when we put that into the calculator, we will get 862.4. And I did not round this. Notice I didn't turn that into 108 or anything. I put exactly what it was on my calculator. I did 15.4 and I multiplied it by 7 and it was exactly that. Make sure you don't round too early, or don't round at all before the very end. Okay. Okay, next problem. So here we have the radius. We have the length of one of the sides, but we are trying to solve for, this didn't get written in, sorry. Solve for the shaded area. Okay. So basically all we need to do is take the circle and subtract the regular polygon. Polygon, there we go. So we know our circle formula. It's pi r squared. We learned that a few classes ago. And then we have our regular polygon formula, which is 1/2 AP. Okay, so pi times the radius squared. So notice why this is called a radius. Well, it's the same. It goes to one of the vertices. It's called a radius up here, and it also is a radius down here. So it's kind of interesting how that works out. So 5 squared is 25, and then we need to figure out our, all right, and the way that we find this apothem is, I'm going to go ahead and draw it in. So it's just from the center of the regular polygon to the edge. It doesn't go all the way out to the edge of the circle. And that makes a right angle. So if you'll notice, we have a right triangle. And we know that this entire side is 6. We also know that we can cut that in half. And it's supposed to be a 3. You can't see it though. And the base of that triangle is 3. So I have 3 and 5 in a right triangle. And I can use Pythagorean Theorem to solve. So to find my apothem, I can do a squared plus b squared equals c squared. This is an easy one. This is actually a Pythagorean triple. So it comes out to a whole number. So 9 plus b squared equals 25. When we subtract it, b squared is going to be 16. That's 25 minus 9. Take the square root of both sides, and you get b is 4. That is our apothem. Okay, so our apothem is 4, but we need that perimeter, right? So we have 4 for the apothem. Our perimeter is going to be 6, because that's the length of the side, times 6, because that's how many sides there are. This is a hexagon. So you get 36. All right, now we have everything we need. We have 4 times 36. Okay, so 1/2 times 4 times 36 is 72. So we have 25 pi minus 72. If the problem wants it in exact form, that would be it. If it wants us to go ahead and multiply by pi, we can do that. 25 times, we're going to use 3.14 for pi. And then, so that's 78.5. We're going to subtract 72. And we get 6.5. So what we have is 6.5 is the area, that shaded region. So what's left over after we subtract the area of the regular polygon. Okay, and then this says to find the central angle in the polygons below. And trust me, there is a method to my madness. There's a reason we're doing this. And that reason is so that we can eventually find the lengths of the apothems and the sides of the triangle. But let me get you there. So to find this angle right here, that central angle, the formula is 360 divided by 2 times the number of sides. And the reason is this angle is going to be half of one side of this triangle. Okay? And so if it's half of one side, that means we need to multiply each side by 2. So 360 divided by 2n, this would be 360 divided by 2 times 5, because there's 5 sides on this pentagon. So that would mean the central angle for this one would be 36. The central angle for this equilateral triangle, so this angle right here, would be 360 divided by 2 times number of sides, which is 3. I'll just go ahead and write 3 in. And that would be 60 degrees. So that is that central angle. Okay? And yes, we will be using these right now. So I just wanted to make sure you knew how to solve for those. Okay, special right triangles. Remember how to do these? The next two examples, we're going to use these to solve for the area. Okay, we're actually going to use this one only. Remember, it was also labeled, sometimes it was labeled like this, leg, 2 times the leg, and leg root 3. It's however you want to do it, whichever way you are more comfortable with. You can label it. You can either use a variable or you can use the word leg. Okay? Okay, so what's our ultimate goal here? To find the area. 1/2 AP. That is going to be our area. How do we do that? We have to find the apothem and we have to find the perimeter. We're given the radius. That's neither of those things, so that does not help us very much. So our first step, what we're going to do first is to find the central angle. And then we're going to solve for the apothem and perimeter. And to solve for the perimeter, you need one of the sides of the triangle. Okay, so let's go for it. We have an equilateral triangle. Instead of doing this work again, we've already done it. So 360 divided by 6 is 60 degrees. That is the central angle. That's the measure of this right here. And then the apothem creates a right angle. So we have a 30, 60, 90 triangle. I'm actually going to zoom this in so you guys can see it a little better. I'm going to draw this triangle a little bigger below. So we have my 30, 60, 90 triangle, 14 units long there. Oh, let me make that a little more clear. And I'm going to label this 2 times the leg, because that's my hypotenuse. This is coming straight from up here. My short leg, which is across from 30 degrees, is going to just be called leg. And then I have leg root 3. Better watch out. I'm going to label it wrong. Okay, and then if you guys remember how we solved, we need to solve for the leg. So we have labeled all of these. We need to set 2 times the leg equal to 14. So what did we just do? We just figured out what is the leg by itself. It's 7. Okay? The leg by itself is 7. Let's label that on our triangle up here. We have just found our apothem. So our apothem is 7. What's the length of the bottom of this? Well, if the leg is 7, then the length of this side is going to be 7 times the square root of 3. Okay, because all you're doing is plugging the leg in, which is 7. So this side is 7 root 3. Okay, we know that if half of one side is 7 root 3, a whole side is 14 root 3. Okay, so if a whole side is 14 root 3, the perimeter is going to be 14 root 3 times 1, 2, 3 sides on the shape, 3. So we have 42, I'm just gonna mess up, 42 root 3 as our perimeter. We have our apothem. So we have 1/2 7 times 42 root 3. Remember, put everything in the calculator except that square root 3. These answers are going to be multiple choice, and you will find your answer in simplest radical form. So 147 root 3 is going to be an answer. Okay, last page of notes. Only 3 examples left. All right, we have same idea here. First step, 360 divided by 2 times the number of sides. There's 6 sides on this shape. So we have 30 degrees for our central angle. Sweet. First step is done. We know that 10 root 3 is the length of this entire side, so we need to cut that in half to figure out the length of that side. What's really nice is that we actually already have the perimeter. So last problem we were given the radius, so we had to find both the apothem and the perimeter. This time we're given one of the sides, so we can just go ahead and figure out what that perimeter is. 10 root 3 times 6. Why is it times 6? Because that's the number of sides. So 60 root 3 is our perimeter. We just have the apothem left to find. So that's what we're looking for here. I've got my triangle. I'm going to go ahead and draw it a little bit bigger. So 30, 60, 90, 5 root 3. This is what I'm looking for. But instead of labeling the x, I'm not going to do that. Okay? I'm going to label this leg root 3, and 2 leg. If you label it x, it's going to get confusing. But I want you to notice something here. Our leg, our short leg that's across from 30, is 5 root 3. So for us to find our apothem, which is this one right here, we need to take our leg and we need to multiply it by the square root of 3. So here's my leg. I need to multiply it by the square root of 3. This confuses people sometimes because it already has a root 3 on it. But the leg all by itself has a root 3 on it. If we want to go from leg to leg root 3, we've got to multiply it by root 3. So it becomes 5 times the square root of 9. And you guys know that the square root of 9 just becomes 3. And so our apothem is actually 15, so it's a nice pretty whole number. Okay, we have everything we need. Our perimeter, our apothem. Let's go ahead and plug those in. 1/2 AP. Area equals 1/2 15 times 60 root 3. I do not know why I keep closing these parentheses. I'm just going to rewrite it next to it. 15 times 60 root 3. Then I want to close the parentheses. And then once I have that, I'm going to put all the numbers into the calculator, but not the square root 3. And I get 450 root 3. And that is my area. So that's what I would look for. Okay, that's using special right triangles. Last thing is using trig. Alright, these are the last 2 problems. And we have to use trig for these. And the reason we have to use trig, if you notice, the problems before had a hexagon and a triangle. And that central angle, when we divided it out, it ended up being either 30 or 60. Well, these central angles are a little different. So that's still going to be our first step, is to solve for the central angle. This is a 7-sided shape. 1, 2, 3, 4, 5, 6, 7. We're going to assume that it is regular. It doesn't look like all the sides are the same, but we're going with it. So 360 divided by 2 times 7 is still going to be our first step. And we get 25.7. We're just going to round everything to the nearest 10th in this process. Okay, if you need to round it to the nearest 10th. So 25.7 is what we're going to get for our central angle. And so I'm going to actually bring this triangle down here, where 5 is the apothem. This is 25.7. We are looking for this side because we want to find the length of this side. We already have the apothem, but remember we need the perimeter, 1/2 AP. It's going to give us our big area. Our apothem is 5. We don't know our perimeter yet. Okay, so we're going to use trig. Let's see if we remember this. I'm going to use a different colored pen and circle this and label my sides. So we have nothing on the hypotenuse, so we don't want to label the hypotenuse. Yeah, this is a right angle. Just like that one up there, I just moved the triangle. And this one's opposite, this one's adjacent. So we have O and A. We know we're going to use tangent because that's opposite and adjacent. We don't have the hypotenuse, so we're not using sine or cosine. So tangent of our angle, which is 25.7, we circled it right here, is equal to x over 5. And if you guys remember, when x is on top, you're going to multiply. So remember where we cross multiply, put a 1 under, and x equals 5 times tangent of 25.7. So x equals 5 times, there we go, tangent 25.7. I'm going to round this to the nearest tenth. So 2.4 is going to be what x equals. Alright, so we know that if one side of the if 1/2 is 2.4, then when we multiply that by 2, we get 4.8 for one side length. Right? Does that make sense? 2.4 is this long. We want the whole thing, so 4.8. There's 7 sides, so to find the perimeter, we take 4.8 and multiply it by 7. So I will do that. 4.8 times 7. You get 33.6. That's going to be your perimeter. So now you have everything you need to solve. So if my area equals 1/2 AP, then area would be 1/2 5 times 33.6. So I could take 33.6 times 5, divide that by 2, and I would actually end up getting a whole number. Doesn't happen every time, but sometimes you will end up with a whole number. Okay, that's one example. We're going to do it one more time. This is now an octagon. So if I have an octagon, I know that that's 8 sides. So we need to take 360 and divide it by 2 times 8. So basically 360 divided by 16. And you get 22.5. So last time it was 25.7. This time is 22.5. I'm going to take a different colored pen so it shows up. Okay, same idea here, except instead of giving us the apothem, we're now giving it a side length. So make sure you cut that in half, because the whole side length is 4, or is 8, but half of it's going to be 4. Okay, we're going to circle our central angle. This is what we're looking for. We're looking for our apothem. So if we are labeling our sides, this is our reference angle. 4 is opposite. X is adjacent. Looks like we're using tangent again. So tangent of our angle, it's 22.5 this time. Remember, you find that every time. Depending on the number of sides on the shape, this angle is going to change. It's going to be equal to opposite over adjacent. So this time it's 4 over x. Ooh, x is on bottom. If you remember, when x is on bottom, you have to divide. You guys remember that? So if you cross multiply, you get x times tangent of 22.5 equals 4. We want x all by itself though, so we divide by tangent of 22.5 on both sides. So x equals 4 divided by tangent of 22.5. So I'm going to put that in the calculator. X equals 4 divided by tangent of 22.5. So we're actually going to end up with 9.7 here, because we're going to round everything to the nearest tenth as we go. So x is going to be 9.7. Therefore, we now have our apothem. So our apothem is 9.7. Our perimeter, we don't know yet, but we have the tools to figure it out, is 8. And then there's 8 sides. So we need to take 8 times 8. Each side is 8 units long. There's 8 sides. 64 is our perimeter. And that pen is trying to give out on me. So the area equals 1/2 AP. Area will be 1/2 times 9.7 times 64. So I will take 9.7 and 64, multiply it together, divide by 2, and I will get 310.4. And that's going to be my area. All right, that's all.